In 2024, the Nobel Prize in Physics went to John Hopfield and Geoffrey Hinton for foundational discoveries behind machine learning with neural networks. Physics for AI. It fits because their ideas came straight from physics, from how systems settle into low-energy, stable states. At the heart of it sits one beautiful concept, the energy-based model. An energy-based model gives every possible state of the system one number, its energy. Picture a hilly landscape. The patterns we want sit low in the valleys, the ones we do not sit high on the hills, and the system rolls downhill toward low energy. Physics gives the exact link to probability, the Boltzmann distribution. The chance of a state falls off exponentially as its energy rises. Low energy means high probability. Hoffield's insight in 1982 was to use this landscape as a memory. He wired neurons together with symmetric connections and defined an energy the network always decreases. The trick, shape it so each stored memory becomes its own valley. Show the network a noisy or partial pattern, and it rolls downhill into the nearest valley, recovering the clean one. Associative memory built out of energy. Hinton took the next step. A Boltzmann machine is a Hopfield-style network made stochastic. Instead of strictly rolling downhill, each neuron turns on or off with a probability set by that same Boltzmann rule. The randomness lets it escape shallow traps and explore. It also adds hidden units, neurons for features you never directly observe, so the network captures deep structure instead of just memorizing patterns. How does it learn? By reshaping the landscape. In a positive phase, it sees real data and lowers the energy around it, digging valleys where the data lives. In a negative phase, it dreams up its own samples and raises their energy, flattening the valleys it invented. Repeat, and the landscape comes to match the world. The restricted Boltzmann machine, with no links inside a layer, made this fast. This was not just elegant theory. In 2006, stacking restricted Boltzmann machines let Hinton train deep networks for the first time, the spark that reignited deep learning. And the energy view never left. Minimizing an energy still echoes through today's diffusion and score-based models. Physics gave AI a language for probability and structure. So that is the Boltzmann machine. Take the physics of energy, build a network that prefers low-energy states, make it stochastic so it can explore, and let it sculpt its own landscape to match the world. A Nobel Prize-winning bridge between physics and intelligence. If you enjoyed this, we are brand new to YouTube, so please subscribe and like, it really helps. Thanks for watching.